Today, I'm going to be talking about Chapter 4.3, Derivatives and Graphs. So just to review some background information, if the derivative of a function is equal to 0, then that function is constant. If the derivative of a function is greater than 0, then that function is increasing. And if the derivative of a function is less than 0, then that function is decreasing. Today, I'm going to show you how to identify critical numbers, areas of increasing and decreasing, local maximums and minimums, concavity, and points of inflection. So first, I'll use the first derivative test, which shows that if the first derivative of a function goes from negative to positive, there's a local minimum. If it goes from positive to negative, there's a local maximum. And if the sign stays the same, there's no local maximum or minimum. This is shown in these two graphs, where the first derivative is going from positive to negative, which also means the function itself is increasing to decreasing. There's a local maximum. If the derivative of the function is going from negative to positive, or the function itself is going from decreasing to increasing, there's a local minimum. So here's our example. First, we find the derivative of the function. Then we set it to 0 in order to find the critical numbers, which in this case are -1 and 1/2. Then we use a table to identify where the derivative is positive and where it's negative, which also means where the function itself is increasing or decreasing. So here are our critical numbers, and here are some test values that we plugged in. We got that in this column that the derivative of f of x is positive, which means the function itself is increasing. Here it's negative, which means the function is decreasing, and again it's positive, which means the function is increasing. Therefore, we can say f of x is increasing from -infinity to -1 and 1/2 to infinity, and f of x is decreasing from -1 to 1/2. We also know that there's a local maximum at x equals -1 because there's a sign change in the first derivative from positive to negative. We also know there's a minimum at 1/2 because, again, there's a sign change at 1/2 from negative to positive. I get these two y values from plugging in the x values into the original function. Next, we have the second derivative test. The second derivative test says that if the first derivative of a function is equal to 0 and the second is positive, then there's a relative minimum. It pretty much means that there's a flat spot and it's concave up. If the first derivative is 0 and the second is negative, then there's a relative max, which means there's a flat spot that's concave down. So here's our example again. We know that, here's our example again. The critical numbers are the same, and here's the second derivative. When we plug in the critical numbers into the second derivative, we find that f of x has a relative maximum at x equals -1 and a relative minimum at x equals 1/2, which we also identified in using the first derivative test. Next, I'll talk about concavity and points of inflection. There's 4 different types of concaves. There's concave down, increasing, concave up, increasing, and concave down, decreasing, and concave up, increasing. The point of inflection is where the concavity of a function will change, like this. And in order to find it is where the second derivative of a function changes signs, or when the first derivative goes from increasing to decreasing or decreasing to increasing. And here's a follow-up on our original function in order to find the concavity. So here's the second derivative, and here we're looking for the critical numbers, so we set it equal to 0. The critical number is negative 1/4, so I've made a table that shows the critical number and 2 test values, and you can see that the second derivative is negative and then positive, which means the first derivative is decreasing then increasing, which means the original function is concave down and then concave up. We also know that the point of inflection is x equal to negative 1/4, which is where the signs change because it goes from negative to positive. Thank you.